No. Hi, welcome. This is Group 15, our lab report 6 for impedance, phase shift, and filter. My name is Eric Osmundsen, Panther ID 6397663.
My name is George Habib, Panther ID 5625224. The objectives for today's lab to analyze a low pass, high pass, and band stop filters with an op amp in multi-sim. We want to simulate these using CAD, build a filter, measure filter, and discuss various filter performances.
So for activity 1, we were asked to set up the following RC circuit in multi-sim. We were asked to then measure and make plots of voltage input and voltage of the capacitor, and graph and measure the phase shifts between the voltage input and voltage capacitors. For resistor, I chose a 470 ohm resistor. Capacitor is a 0.47 microfarad, and voltage input is 200 millivolts. For A, the frequency came out to be 720 hertz. The delta was 236 microseconds, and the phase shift from those two values came out to be 61.4 degrees. For B, I came out with a frequency of 360 hertz, a delta of 397 microseconds, and a phase shift of 51.6 degrees. For C, it was a frequency of 72 hertz, a delta of 662 microseconds, and a phase shift of 70.2 degrees. For D, frequency was almost 1.5 kilohertz. The delta was 151 microseconds, and the phase shift was 78.6 degrees. And lastly, for E, the frequency was 7 kilohertz. The delta was 34 microseconds, and the phase shift turned to 88.4 degrees.
For activity 2, we were giving 4 filters made up of op amps. We were told to sweep the frequencies for different ranges and graph in order to be able to classify each filter into either low pass, high pass, band pass, or band stop. Here we have the multi-sim simulation for filter number 1. Here we have the graph of the magnitude versus the frequency of filter number 1. Here we have the output versus frequency, or the phase versus frequency, sorry. And the conclusion of that is that as frequency increases, output decreases. So it is a low pass filter. Here we have the multi-sim simulation for filter number 2. The frequency versus the magnitude of 2 is graphed here. Here we have the frequency versus the phase of 2. And to conclude here for number 2, when the frequency increases, the output decreases. So it is also a low pass filter. Here we have the multi-sim simulation for filter number 3. Here we have the graph for the frequency versus magnitude of number 3, the frequency versus phase of number 3, and to conclude for number 3, when frequency increases, there is no change in output, so it is a band pass filter. Here we have the frequency versus magnitude. Sorry. We have our multi-sim simulation of number 4. And now we have the frequency versus magnitude of 4, the frequency versus phase of 4, And finally, our conclusion that when frequency increases, output also increases. So this is finally we have a high pass filter that allows high frequencies.
So in conclusion for the lab, we learned that a low pass filter allows for the passage of low frequency signals while attenuating high frequency signals. A high pass filter allows for the passage of high frequency signals while attenuating for low frequency signals. The band pass filter allows for the passage of signals within a specific frequency range while attenuating signals outside of that range. And the band stop filter allows for the attenuation of signals within a specific range while allowing signals outside that range to pass. That concludes our lab report. Thank you.
Thank you so much. All right.